All right, so we need to learn about rates of change briefly. So, a rate of change is actually not so bad. All it is the change in the output per change in the input. So, I claim you guys already know a bunch of things like this. Basically, you know a bunch of stuff where the units are in somethings per something else. Right? So can you give me examples that you guys know of?
Miles per hour.
Good. So miles per hour, what is that changing?
Changing miles.
Distance.
Yeah, that's the,
Distance over time.
so that's a change in distance per change in time, right?
Mm-hmm.
You guys with me on that? Okay, what else you got? Got another one of these?
Meters per square inch.
Meters per, okay, yeah.
Same thing though, yeah.
There's a whole bunch of these, right?
Dollars per hour.
Good. Right? That's like a change in not a change in income, right?
Change
Change in salary.
Salary.
No.
Change in pay. Change in wage.
Money.
Change in the amount in your wallet,
Yeah.
right? Per
Time.
You guys with me on that?
Yeah.
What about slope?
Good. Slope is a great example. Right? That's what? What's slope give it? Yeah, that's the change in y's over the change in x, right? Good. Which is a rise over a run, right? You guys see that?
Yeah.
So the slope of a line is a rate of change, right? That said, most things aren't actually lines. Like, this one might be a line, right? Assuming I do the same job basically all the time.
Yeah.
But it's not necessarily true. Like, my wife has like 4 or 5 different things that she does. She kind of works for herself, and so she has a bunch of little jobs, right? Like, picks up some teaching time from the University of Wisconsin sometimes. Sometimes she judges ice climbing competitions for the World Cup. Sometimes she works as a climbing guide. Like, she has lots of different rates of pay, right?
Mm-hmm.
And so she doesn't have just one line here, right? It depends on who she's working for that day. You guys see that?
Yes.
All right, how about your miles per hour? When you drive around,
Mm-hmm.
is your miles per hour just like,
Stay constant? Absolutely not.
no. Does it stay constant even at a constant rate?
No.
No. Crap. So we need to, I think we're going to have to figure out some way to do rates of change for things that aren't lines.
Well, isn't acceleration versus like speed?
Oh, yeah. Okay, good. So that's a good example. So if we had position as a function of time, right?
Right.
The rate of change of that. So what's the rate at which position changes with respect to time? What is it?
Just give you one.
No, what's the name of that function? Close.
Rate of velocity.
Yeah, that's velocity. You guys see that?
Yeah.
So I'm writing rate of change here.
Rock.
I like rock.
Let me write a fancier symbol. This symbol means rate of change. The resemblance I want you to catch is that the D's are kind of these guys, and the T is your input. You guys see that?
Yeah.
Yeah, that thing's called a derivative. This is pre-calc though, right? So I'm not going to tell you how to calculate that or show you anything about it except to say that that symbol is a shorthand for me to get the rate of change of a function. Okay? What is the rate of change of velocity? Acceleration. So if we do another one of these guys, we'll get to acceleration as a function of time. You guys all see that? Does that make sense? What are the units on accelerations?
Meters per second square, like just like.
Yeah, so we say this meters per second squared, right? Let me think about that as meters per second per second. You guys see this? So this is a change in velocity per change in time. You guys see that? And that's what a change in distance per change in time, that was a velocity. Just with me on that? Okay, now, for extra points.
Change in acceleration.
Yeah, what's the change in acceleration per change in time?
Gravity.
Gravity, man.
Gravity's an acceleration.
That's just also.
Wow, so yeah, gravity's an acceleration.
Oh, constant. It's like a constant.
Don't believe the truth.
It's not.
So what I want you to think about is how do you get these in your car? So what's the position function look like in your car? No.
Odometer?
So the velocity thing is the speedometer, right?
Okay, right. So the position, you just look around and you hear GPS. Yeah, exactly.
Yeah, GPS would be this. What else would? There is a dial on your car. No. There is a dial on your car that indicates the nice.
That's what I said.
The odometer. What's the odometer measure?
Miles.
How many miles the car has been,
Yeah.
right?
Mm-hmm.
So that's like literally the total change in position over the car's lifetime.
Yeah.
You guys see that?
Yeah.
Okay, so that's your position measure. That measures how far the car has gone at all.
Oh.
Your speedometer measures your velocity.
Oh.
Well, really it kind of measures your speed, right?
Yeah.
But I don't even know what a speedometer does in reverse because I've never looked at it. Right? Because I'm always like looking behind me when I'm backing up, never looking at the dial. What's the acceleration in your car? Where's that?
RPMs?
Yeah, that's kind of your tack. Well, depending on what gear you're in, right?
Yeah.
Really, maybe the most obvious thing for it is where's the accelerator, right? Like where's the gas pedal?
That makes sense.
Yeah, if we really wanted to.
The angle of your feet. That's the foot.
Yeah, you could think about it as the angle of your foot. Really, if I was doing a great job with this, I wouldn't be using a car. I'd be using an electric car because they don't have gears, right?
Right. Yeah.
So I'd be saying, okay, so in your electric car, the odometer is still an odometer, right? The speedometer is still a speedometer, and the gas pedal actually is directly the acceleration. Right? Well, it's not actually, I'm lying to you, but
It feels like it does.
yeah, so they kick the gas pedal on a little bit differently, right? So the first couple millimeters of travel make make less difference than some of the ones midway down, because they don't want you to like tap your foot against the accelerator and have it like jerk around in the garage. Okay, so what's the other one?
Break.
Good. The brake is a way to get added acceleration.
What is
That's
If you do the brake,
Rotations per minute.
yeah, what's the other one?
No, like what are we figuring out?
So I'm trying to figure out what the change in acceleration over time, right? What's the rate of change of acceleration look like?
Reverse, man.
No.
It's like
It's right? This was the total position, right? And then we did, what's the rate at which the odometer is changing? That's the speedometer. What's the rate at which the speedometer is changing? That's how far you're pushing down on the gas.
So is it U? Are you?
Yeah.
Oh.
So this is the rate at which you're pushing down on the gas pedal, right? You guys see that?
Yeah.
It makes more sense for the name if I tell you it's the rate at which you're stomping on the brakes. Because what happens when you stomp on the brakes?
Yeah.
Right? What do you call that?
Whiplash.
Yeah, like whiplash, or like what would you call it if you yanked on something really hard? Like other than a yank, there's a word for that.
A pole.
Yeah, that's what I was.
An abrupt yank
And abrupt yank would be us.
is it's a name for somebody you don't like very much.
A jerk.
A jerk.
Jerk. Wow.
Right? So the last one is jerk. And that's that really kind of is you, right?
Yeah.
That's the change in angle for your foot on the floor.
Yeah. That makes so much sense.
You guys follow this?
Yeah.
So this is why we. What's up?
Wait, what's happening with the
This
last
is
one?
the change
That's
in
good.
angle, right? The rate at which
Angle,
you're
okay.
pushing down on the gas pedal.
I didn't know what that was for a second.
Yeah, no worries. I kind of wrote it because these guys were talking about the angle your foot makes.
Right.
You guys follow this?
Yeah. I know. And somebody's
Kind of makes sense? So this is why we study rates of change, though. Because usually what we know about is something like Zach mentioned earlier. I know about gravity. Gravity is one of these. Right? Like everything in the kind of more or less uniform gravitational field we live in has an acceleration of 9.8 meters per second happening to it, right?
Yeah.
If I want to know how stuff acts when I drop it,
Mm-hmm.
I need to start from knowing an acceleration and back up this thing. You guys see that? So we're going to spend a lot of time learning about going down this thing, really, so ultimately we can go back up it and do a little physics.
Nice.
You guys cool with that?
So.
Okay. So other rates of change. Let me stop this video.